All right, good evening, everybody. We are going to continue our discussion on ionic bonding. And instead of putting things in our notebook, we're just going to jot a couple things down right here on these worksheets that you should have. If you don't have the worksheets, then you can go ahead and just put this in your notebook. Okay, so we have ionic bonding. So ionic bonding, in order for them to become a bond and make a salt crystal, which is what these are going to do when you have a metal to a nonmetal, they are going to transfer electrons. And this transfer of electron is always going to happen from a metal to a nonmetal. And that's what's always going to happen in ionic bonding. And so in here, there's going to be opposite charges then, because the metal is going to become positive, the nonmetal is going to be negative, and we should know from prior experience that a positive and negative attract to each other, and these are going to form salts. So they transfer electrons from a metal to a nonmetal to form a salt. So I hope you're thinking plain old table salt that you have at home. Yes, you are exactly right. Okay, so the first thing it says here, we're going to draw valence electrons on the beginning atoms on the left-hand side is step 1. Step 2, we're going to draw arrows showing the electrons being given from one atom to another. And step 3, we're going to draw electrons and the resulting ions on the right side. Okay, so you should have your periodic chart here in front of you. And so we have potassium and chlorine, so we have to find the number of valence electrons. So our periodic chart that we've been using, we have potassium, which is right here. So it has 1 valence electron. And something in family 7. Chlorine, I think. Chlorine in family 7. So we can see that they are going to be able to bond to each other because one's going to give up one and one is going to gain. So potassium, it has 1 valence electron, so we'll put 1 dot on here. Chlorine had 7. So 1, 2, 3, 4, 5, 6, and 7. Then we're going to draw the arrow showing the electrons being given from one to another. And we know metals want to give up their electrons. So the metal is going to give it away here. So that's going to go and pair up right there with the chlorine. And then we're going to draw the electrons and the resulting ions on the other side. Well, I gave up that 1 electron, so there's nothing there for the potassium. But because it gave up 1, that's going to have a +1 charge. And then the chlorine, we are going to fill this. So now we have 8 electrons over here, okay? And that gained 1, so that became a potassium ion with a +1 charge, a chlorine ion with a -1 charge. So we can say that I have K +1, Cl -1. Again, we write those as superscripts. +1 and -1 cancel out. So there is my formula, KCl. And let's see, let me move that down so I can write the name underneath that. And so again, from the last worksheet that we had, the metal is going to stay the same, potassium. And then instead of potassium chlorine, it's going to become chloride because the nonmetals have an IDE ending. So that's it, you guys. That's all we're going to ask you to do on this one. So let's see. We can try this calcium one. If we take a look at calcium on our periodic chart, we can see that calcium is over here, has 2 valence electrons. And I forgot what it was with. I think it was with bromine, maybe? It was something with the halogen, so it had 7 valence electrons. I really should have my sheet in front of me so I'm not making mistakes here. And, oh, it was bromide. So calcium has 2 valence electrons. So I'm going to put the 2 dots right here. And then bromine had 7, so go ahead and draw 7 around that. And I would do it around 2 of them because it tells me that I have 2 bromine atoms, and I hope that you're kind of thinking in your head, oh, I think I might know what Miss Benson's going to do next. So now we have to figure out is that calcium, to satisfy itself, needs to lose both of these electrons. It's never just going to lose one. It's either going to lose all or none. And so the bromine only needs one electron, though, to be satisfied to get 8. So, but the calcium can give up 2, so I'm going to need 2 bromine atoms every time a calcium is nearby. So this is going to have a +2 charge. This is going to be -1, -1. Go ahead and draw in the 8 electrons, showing that that 1 electron comes in. On my answer key, you might see that I might have put X's as to where that 1 electron is coming in. Okay, so I have 1 calcium and I have 2 bromine. So I write it like that, CaBr2, and the name here is going to be calcium bromide. Okay? All right, that's it for that page. You guys can go ahead and do the front and back of that. I do want to show you a little bit on this next one. We're going to do it a little bit shorter on number 6. It says solve the problems using electron dot diagrams. Draw the electron dot diagram of all the elements in the ions that you need to create the ionic compound. So I have sodium and chlorine. So when I draw sodium and I look on my periodic chart, I'm going to see that sodium has 1 valence electron and chlorine has 7. Okay, now I want to draw the ions. So I decide that sodium is a metal, so it is going to lose both or lose one of its electrons. So I draw Na plus 1, and I know chlorine is going to take in 1. So it's going to look like this. And it's going to take in 1, and it's going to have a -1 charge. And so the formula, the formula is going to be NaCl, and the name, sodium, remember the metal does not change, and the anion does, sodium chloride. Okay, I hope this will help you out to give you some idea of how these salts form. I hope you have a great night.